Hello everyone, welcome back to Mars Explore Hub. And before we begin this unimaginably massive, ultra-extended, hyper-detailed documentary-style narration about the Red Planet, make sure to subscribe to the channel, because today's topic is designed not for a few minutes, but for an extremely deep journey into the heart, history, mysteries, science, geology, atmosphere, climate, and future colonization of Mars. Written as one continuous flow, so enormous that it stretches far beyond ordinary storytelling, reaching into the scale of an entire documentary script, exploring Mars from every possible angle, beginning from its formation billions of years ago, through its volcanic age, watery past, atmospheric collapse, frozen deserts, scientific missions, rover discoveries, and all the way into humanity's future among the Martian landscapes. Mars, the fourth planet from the Sun, formed around 4.6 billion years ago, when swirling dust and rock fragments in the early solar system collided and fused under gravity, slowly building a rocky world that would one day become a place of immense fascination for humans. In its early history, Mars was a warm, wet, and active planet, with powerful volcanoes shaping its surface, molten lava lakes cooling into thick crustal plates, tectonic cracks forming massive valleys, and a magnetic field strong enough to shield its atmosphere from the solar wind. This protection allowed Mars to maintain a thick atmosphere filled with carbon dioxide, nitrogen, and traces of water vapor, making it warm enough for liquid water to flow freely across its surface. Scientists, through rover and orbiter observations, have identified ancient riverbeds, deltas, and lakes that show Mars once had a global hydrological cycle similar to Earth, complete with rainfall, flowing rivers, sediment deposits, and standing lakes. Curiosity rover found evidence of long-lasting freshwater lakes in Gale Crater. Perseverance is now exploring the remains of an ancient river delta in Jezero Crater, a place where life could have existed billions of years ago. During this era, Mars may have been teeming with microbial life in warm, shallow lakes, deep underground aquifers, geothermal hotspots, and hydrothermal vents near volcanic regions. The presence of clay minerals, sulfates, carbonates, and organic molecules discovered in Martian rocks confirms that Mars once had environments suitable for life. But something catastrophic happened. Mars's internal core cooled much faster than Earth's due to its smaller size. As the core cooled, the magnetic field weakened and faded away. Without the magnetic shield, the sun's intense radiation began stripping the Martian atmosphere into space, molecule by molecule, slowly decreasing air pressure until the planet could no longer support liquid water on its surface. Rivers dried up, oceans vanished, lakes evaporated, and the planet transitioned into the cold desert world we see today. Despite this, billions of tons of water still remain frozen in the polar caps, buried under layers of regolith, and possibly in deep underground reservoirs that remain liquid due to pressure and salts. Even now, Mars experiences mysterious seasonal methane spikes, detected by Curiosity rover, suggesting that something beneath the surface may still be active, either geological reactions or potentially microbial life trapped underground. Modern Mars is a world of extremes, dust storms that can blanket the entire planet, temperatures that can swing dramatically from near-freezing days to extremely cold nights, and an atmosphere so thin that liquid water cannot exist on the surface for long without evaporating or freezing instantly. Yet despite these challenges, Mars remains humanity's best candidate for future colonization. Space agencies and private companies like NASA, ESA, ISRO, CNSA, Roscosmos, and especially SpaceX, with its Starship program, envision a future where humans live on Mars in pressurized habitats, farm food in greenhouse domes, 3D print buildings using Martian soil, melt subsurface ice for drinking water, and extract oxygen and fuel from the Martian atmosphere. Engineers plan to use Martian regolith to build radiation-shielded shelters, while scientists develop closed-loop life support systems capable of recycling air, water, and waste. Nuclear reactors or massive solar farms will provide energy for the growing colonies. Lava tubes, giant underground tunnels formed by ancient lava flows, may serve as natural shelters from radiation, micrometeorites, and the harsh climate. In these tunnels, future Martian communities may build entire underground cities with artificial lighting, hydroponic farms, research laboratories, hospitals, schools, and manufacturing facilities capable of producing tools, electronics, and transport vehicles. Over centuries, humanity may attempt partial terraforming, releasing greenhouse gases like CO2 trapped in Martian soil, installing orbital mirrors to melt polar ice caps, or even importing ammonia-rich asteroids to thicken the atmosphere. These processes would take centuries or thousands of years, but even small changes could make Mars warmer and more habitable. The journey to Mars represents not just scientific ambition, but the human spirit's unstoppable desire to explore beyond frontiers. Every rover that sends images, every orbiter that maps its surface, and every mission that uncovers clues about ancient water brings us closer to understanding Mars's history and our own. Mars is a place where humanity will test its limits, challenge its fears, expand its horizons, and write a new chapter in interplanetary existence. The red planet stands waiting, silent in its dusty beauty, ready to welcome the first humans who will transform dreams into reality, turning Mars from a distant world into a new home for generations. As we continue our long journey into the mysteries of Mars, it becomes clear that the story of this red world is far bigger than a simple tale of rocks, dust, and barren landscapes. Mars is a planet that whispers ancient secrets through its frozen valleys, gigantic volcanoes, and dried riverbeds. Its surface holds clues to a past that may have once been warm, wet, and alive. When scientists examine the layered cliffs, the sedimentary rocks, and the mineral signatures left behind by water, they realize that Mars is not just a planet, it is a preserved history book of the early solar system. Each layer of rock acts like a page in that book, describing millions of years of climate changes, atmospheric loss, and geological transformations. The more scientists dig into the Martian soil, the more they discover how complex the planet truly is. For decades, Mars rovers such as Opportunity, Curiosity, Perseverance, and the Ingenuity helicopter have gathered enormous amounts of data, helping humanity piece together the puzzle of Mars's evolution. These robotic explorers have drilled into rocks, taken high-resolution photographs, analyzed chemical samples, and detected organic molecules that hint at the possibility of past life. Even the smallest hints, such as methane spikes detected in the atmosphere, raise huge scientific questions. Is the methane coming from geological activity deep beneath the surface, or is it the chemical signature of ancient microbial life trapped in underground pockets? Meanwhile, orbiters around Mars, such as MAVEN, Mars Reconnaissance Orbiter, and Mars Odyssey, have revealed dramatic details about the planet's climate history. They discovered that Mars once had a global magnetic field like Earth, thick atmosphere, and flowing lakes and rivers. But over billions of years, solar winds stripped the atmosphere away, transforming Mars from a potentially habitable world to a cold desert. Yet even now, beneath the thick dust and frozen surface, scientists believe that liquid water might still exist in underground reservoirs, protected from radiation and extreme temperatures. These pockets could still harbor microbial organisms, preserved for ages in the Martian crust. As technology improves, the dream of human colonization comes closer to reality. Engineers and researchers around the world are designing habitats that can survive the harsh Martian environment. Habitats with thick walls, radiation-shielded domes, underground living spaces, and self-sustaining life support systems. 3D printing with Martian soil is being tested, allowing future explorers to build structures using local materials instead of transporting everything from Earth. Solar power, nuclear reactors, and advanced robotics will form the backbone of the first Martian settlements. Every step in these preparations moves humanity closer to becoming an interplanetary species. Another important concept is terraforming, the idea of repairing or modifying Mars's environment to make it more Earth-like. Though still theoretical, scientists propose methods such as releasing greenhouse gases to thicken the atmosphere, melting the polar ice caps to release trapped water and carbon dioxide, or even importing ammonia-rich asteroids to thicken the atmosphere. These processes would take centuries or thousands of years, but even small changes could make Mars warmer and more habitable. The journey to Mars represents not just scientific ambition, but the human spirit's unstoppable desire to explore beyond frontiers. Every rover that sends images, every orbiter that maps its surface, and every mission that uncovers clues about ancient water brings us closer to understanding Mars's history and our own. Mars is a place where humanity will test its limits, challenge its fears, expand its horizons, and write a new chapter in interplanetary existence. The red planet stands waiting, silent in its dusty beauty, ready to welcome the first